Okay, inverse functions, they reflect through the line y equals x. So hopefully you remember the straight line y equals x. It goes right down the middle between x and between y. And if you think about this blue function, the original function, it's reflected through, oops, I didn't do a great job there of reflecting, but it reflects through, and the other one reflects, the rest of it. It's the same on both sides. If you picture a mirror there, the red is being reflected by the blue, or vice versa. Note, please, that after the minus one of x is not 1 over. Usually when we have a number up there, it's an exponent. It means I have something that's demanded to be moved, but not this time. Not if it's function notation. It means the inverse function. Okay, f inverse. It's the same thing. Okay, so the easiest way to do it is to switch the y and the x. Okay, you just switch the y and the x and you solve for y. Don't forget to solve for y, and then you have a new function that is the inverse of the other one. And you can verify that they're the inverse of the other one by plugging it into the other one. So f of x says to multiply by 3 and then subtract 5. So we take this other one here and we plug that in for x, okay? And then we do what we said we were going to do. Multiply by 3, subtract by 5, and that's what we do. Going the other way, it's we say that we're going to multiply by 1/3 and then add 5 over 3. So we're going to take this and we're going to plug it in there. We're going to plug it in and we're going to do what we said. We're going to multiply by 1/3 and add 5 over 3. All right, and in both cases I get x. All right, so if they're inverse functions, that's what happens. I get x when I plug them into each other. So we're going to verify that when we get done. Find the inverse function, the easiest way to do it. You know that f of x does not mean f times x. That is not what we're doing here. This is a function in terms of x, also known as y. So we say y is equal to 2x minus 1. And we switch the x and the y. So we say x is equal to 2y minus 1. Now we have to solve for y, just to get back like we normally are. So we have x plus 1 is equal to 2y. And I'm going to divide both sides by 2. And so I'm going to say y all by itself now. I'll say 1/2 x, because that's x over 2 is 1/2. And then plus 1/2, okay? So I guess I could go back and say that I divided both things by 2. That would probably make it look better. All right, so here's my inverse function. I found it. And now I'm going to check to see if I did that well by plugging them into each other, okay? So I'm going to say 2 times this function that I just created, 1/2 x plus 1/2 minus 1. What does that give me? Well, let's see. 2 times 1/2 is 1, so I get x. And 2 times 1/2 is 1, and then I have minus 1, and that's equal to x. Okay, and then in the other situation, I'm going to do this to that. Okay, so let's see. I have 1/2 x. Well, what's x? It's 2x minus 1. You see that? I'm plugging this in here. Okay, and so I use my parentheses because, there it is. And then it says I'm going to add 1/2, right? So I add 1/2. Okay, so what happens when I do this? 1/2 times 2x is just x. And 1/2 times -1 is -1/2 plus 1/2. The 1/2s cancel and I get x. So yes, they are inverses of each other. It makes sense. I get x whether I go one way or the other. And so that is my inverse function. They are inverses of each other, and that is the answer.